we're going to prove that the sine of alpha plus beta, so the sine of the sum of two angles, is equal to the sine of the first times the cosine of the second plus the sine of the second times the cosine of the first. Okay, to do that, we're going to use the following property. So here's what I'm going to, so this is kind of a side note, and we're going to need this in our proof. So our side note is the following. The side note says we're going to evaluate the cosine of an angle. Actually, I'm going to do it this way. Of 90 degrees minus an angle. So we're going to use this up here. So watch how this goes. The cosine of 90 degrees minus an angle. I'm going to use the difference formula here. So use the difference formula for cosine. So you can see how these things are all kind of starting to fall into place. So this is going to be the cosine of 90 times the cosine of the angle. Okay, and then it's going to be minus, well, this is going to be turned to plus, the sine at 90 times the sine of the angle. The cosine at 90, we know that. We can evaluate that. If you think about the unit circle, the cosine value, the left-right movement at 90 degrees is 0. So this guy is 0. Times the cosine of the angle plus, now the sine at 90 is 1. So this guy ends up just being the sine of the angle. So here's what I've got. I've got that the cosine of 90 degrees minus an angle is equal to the sine of the angle. So I'm going to use that up here. Watch. What I'm going to do is, instead of theta, I'm going to let, so in this guy right here, I'm going to let theta equal alpha plus beta, like that. So watch what happens. If that's true, then I get the following. Then I get the sine of alpha plus beta is equal to the cosine of 90 degrees minus alpha plus beta. So this guy is that over there, and this guy is that over there. So I'm using this is a cofunction identity. We've proven it already. Cofunction identity. We proved it in one of the earlier worksheets, and I believe I called it the cofunction in that as well. But even if I didn't, here it is again. Okay, so we're going to use this trick. So now I've got this, and we know that we can do the following. Okay, so watch. I can go ahead and replace, so 90 minus alpha plus beta. What I can do is go like this. I can rewrite this as cosine of 90 degrees. Okay, so this is, let's make this very clear. This is 90 degrees minus alpha minus beta. Now I'm going to group them like this. There's nothing wrong with that. Okay, so I distributed the negative, and then I just said, okay, I want to put the first two together. And the reason I'm grouping them is so that you can see what's going to happen here. So now let's apply the difference formula. So this is the cosine of 90 degrees minus alpha times the cosine of beta plus the sine of 90 minus alpha times the sine of beta. So let's talk about why this is. This is like my first angle. This is my second angle. And when you take the difference between two angles and the cosine, it's the cosine of the first angle times the cosine of the second minus the sine of the first angle times the sine of the second. So you'll have to excuse that I had to pause the video for a second, so let me kind of catch back up where we were. I was saying that this angle right here is essentially this angle, okay, and then this angle back here. Okay, now what we're going to do is we're going to use the same idea here for 90 minus alpha. So the cosine of 90 minus alpha is equal to the sine of alpha. And the sine of 90 minus alpha is equal to the cosine of alpha. Now, how do I know that? These right here are your cofunction identities. So whenever you have, so let's just kind of write this as a side note. Whenever you have the cosine of 90 degrees minus some angle, that's equal to the sine of that angle. And whenever you have the sine of 90 degrees minus an angle, that's equal to the cosine of the angle. So sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. So this is our results, and that was our proof. Okay, so you should be all set on that one.